Okay, let's talk about the Windows loader. So we understand how a program is being built. Then we understand the properties of a program, And now let's see how is the process when you double click of a program. Okay, that's called the Windows loader. So the first step when you double click on a file, the first thing is that the first step is that the Windows loader is going to map the executable file from disk into an isolated virtual address space. And it is called virtual because basically you will have a space in memory that can have a base address of, like in this case, 400,000. And you can have a second program which can also be loaded at the same address. As you can see, program A and program B both are loaded into the same address, but the trick is a virtual address. That means that those two guys are actually in different physical spaces, but virtually they can represent the same addresses. So that's an easy way for programs to be loaded, but at the end of the day, those are not being overwritten each other, basically. Okay? And as I explained, why those are being used the same address by different programs, as I said, is because those are actually different. It's just virtually the same, but physically those are in different locations. Step 2. So the loader is going to read the virtual offsets and maps each section into the memory address space. Okay, so you will say, okay, you know what? So let's see, my virtual offsets is every 1000 bytes is going to be the difference between the sections. Then when I load it in memory, this is on disk and here is in memory. When the program is running, you can see that now it is loaded into the address B20000, and now the first address text is loaded in the B2 plus 1000, and then next one 2000, so on. You see? So based on these virtual offsets, then the program, once it's loaded in memory, can follow the same separation. Now the program is loaded in memory. Okay, step 2. What's next? Now the program is going to read the import table and maps each DLL into the memory address space. Remember that I told you that import table is being used by executables and DLLs? Okay, so let's imagine that the import table has a kernel 32 DLL. What's going to happen is that the loader is going to say, okay, I need to load kernel 32 into the memory space. It goes and calls specific functions and loads in memory kernel 32 with all the sections ready to be used by the program. And then it's going to call the next DLL and the next DLL and the next DLL. All the DLLs that are in the import table from the executable are going to be loaded in memory by the loader. Step 4. The loader, now that is everything loaded, it goes to the file and looks to the LFA new value to find the P header offset, and from there it's going to find the entry point of the executable and run it in memory. Okay, so it's going to say, okay, this is the image base for the file. Then from there, this is the P header. The P header has the image base. It has the entry point thanks to this guy, LFA new. And then now I know that this image base plus this entry point, this is the address where is my starting point. And then I'm going to just call it. And then I'm going to start running my executable in memory. So you see all those steps that took place once you double click on some file and eventually you get loaded in memory. Okay?